strategies.
Okay, so hi and good morning, everyone. So welcome to MuleSoft Mysore Meetup group. So today we will be discussing about secure communication. So to how we can implement one-way SSL and two-way SSL and for our MuleSoft communication. So today we have Irfan with us, who will be speaking on this. Okay, so before we start our presentation, I'll read out some safe harbor statement. So both the speaker and the host are organizing this meetup in individual capacity only. We are not representing our companies here. All right, and this presentation is strictly for learning purpose only, and organizer do not hold any responsibility that same solution will work for your business requirements. Okay, and not meant for any promotional activities. So housekeeping rules, as we mentioned, like we are recording this, so recording will be uploaded to YouTube page and also to the events page. You can just check that out after within 24 hours. And questions you can ask anytime. We have enabled mics for everyone, so feel free to ask with the speaker at any time and give us feedback. We are looking at that as well. Okay, so now comes to the organizer part. We have two people for this. Okay, so I'll introduce myself. I am Shubham Chaurasya, working as a professional integration developer in Millennium. So that's all about me, and over to you, Giri.
Yeah, thank you, Shubham. Good morning, everyone, for joining us today. So, myself, Giridhar, I'm working at Aston as a senior technical architect. So, I take care of MuleSoft accounts. I'm a certified MuleSoft developer and architect, both even an AWS certified architect as well. I'm leading Mysore Meetup group, and I'm a MuleSoft mentor as well. Today we have Irfan with us for today's topic. Like he's going to walk us through the one-way and two-way implementation, how we can secure the connections or the network using SSL. We have turned on your mics. Feel free to ask your questions if you have any in between during the session, and or put it in the chat. We can take up at the end of the session in Q&A section. And as like Shubham mentioned, feedback is very important. And I mean, we always look for the feedback, and we take up from that whatever the topics are suggesting from you all. We will take up and we will consider, and then we'll come up with those topics as well. So please submit your feedback forms post completion of the meetup. Over to you, Irfan. All the best.
Yeah, thank you so much, Giri. So let me share the screen.
And this is his first session as a speaker, so please encourage him.
Yeah, thank you so much for that. Is my screen visible?
Yeah, it is visible.
So thank you for joining this Mysore Meetup group, and myself Irfan Ahmad, and I'm working as a senior software engineer in Hasdin by Deloitte. So I hold like more than 3.5 years of experience, and I'm as MuleSoft developer. So yeah, let's get started. So the today's agenda would be about you know the SSL handshake, and like what is SSL and what is the TLS configurations and why we use it, and like what are digital certificates, and what is like one-way SSL and what is two-way SSL, and what are the differences between those one-way and two-way SSLs. And also the presentation would be followed by a demo. So we'll start with the introduction now. So yeah, so here comes the like what is HTTPS protocol. So usually just when everyone every day, like
Irfan,
we always hello.
Irfan, sorry to interrupt you. Can you click on that pop-up? You can hide that pop-up in your screen.
Okay, so yeah,
Go ahead.
so fine. Oh, so usually we all go to a website. Any user will go to a website, and usually we surf a lot of websites like e-commerce or social media websites, like a lot of things that we do on with the browsers, right? So when we do such kind of stuff, like when any user, when it's a general anomaly, like when he sees something like HTTPS, starting his website URL with HTTPS, okay, and with a green padlock, and which makes the user to sense like, okay, I am landing up in some secured website, okay, I'm accessing to some sort of resources which are secured. So my data, I can share my data to that particular server or to that particular website, and it is secured. So that trust is built up by the simple padlock with the green padlock, which has this this protocol, which HTTP yes protocol. It was just the yes which was added to the HTTP, which is providing a lot of trust to the users, and for their users to access the website, right? So how this trust is built by the simple adding up the yes to the simple HTTP protocol, which was followed by a lot of mechanism, with this simple yes. Okay, so basically this yes stands for the SSL or the TLS protocols. So we always listen this two phrases like SSL and TLS, which are like interchange phrases. Both are the same. Like the TLS was just the successor of SSL, where the SSL stands for the secure socket layer and the TLS stands for the transport layer security. These both protocols are just used for establishing the authenticated and encrypted links between the systems which are over the network. So let's go and deep dive, or understand, like what is SSL or the TLS protocol, and what are its goals, and what SSL and TLS handshake and how it happens and all those stuff. So usually, basically, the SSL handshake, what SSL handshake has basically three goals. One, the confidentiality, and the other one is integrity, and the third one is authentication. So what do you mean by confidentiality? Confidentiality is, I'm sending some data to you, and you are the only person. I mean, the sender is sending some data to the receiver, and the receiver is the only person who should be viewing the sender's message, not the other one, or everyone else should be seeing the message, which means it's a breach of confidentiality. So that confidentiality can be achieved by encryption, which means like I'm sharing some data to you, not just like a simple plain text, but I'm going to encrypt the data. The sender is going to encrypt the data with some key, and the receiver will have some decryption key, and the receiver will use the decryption key to decrypt the encrypted data, which is providing the confidentiality, or the sender will know, okay, the so what are the message I'm going to send in the encrypted format. The only person who can decrypt is someone having the decryption key. So this confidentiality can be built up by, or the confidentiality goal can be achieved by encryption mechanism. The other goal is integrity. So integrity is something, now I know, like I'm sending the data to the appropriate person, but I'm not sure that my message is going to be sent as it is without tampering in transit. Which means, like I'm sending a receiver, a sender is sending a message hello. The receiver also should receive the message as it is, like hello. It should not be like thank you message, right? So that is something called integrity, and which can be achieved by some hashing techniques. And the third goal is authentication. Authentication is something, okay, no one should be prompt like our sender. For example, the sender is abc.com. No one should prompt like abc.com and try to bully the user, showing that, okay, I am the abc.com. It shouldn't happen. So whoever, the sender, should have to prove his identity, that he is the appropriate person, or the appropriate server, or the appropriate website, whatever. So that comes with some, some identity, and that identity will be provided by some certificates. Okay, so let's go and understand each goal in detail. So as I talked about the confidentiality, which would be achieved by encryption. So how this mechanism works basically, so you have some data, okay, you have some key which is encrypting your data, and you send to the other party, or, or the other party is having the decryption key, and he's using the same decryption key, and he gets the, he can able to decrypt the message. So this encryption, in today's world, we have the two widespread of encryptions, which is the symmetric encryption, and the other one is asymmetric encryption. The symmetric encryption is something, it's the encryption and the decryption key are similar. So I have a key called one and encryption key, and I'm sharing the same key, like one, to the receiver to to use the same key as a decryption key. So that is called the symmetric encryption key. Okay, and the asymmetric encryption is something, you have different keys, which means you have a key pair. Okay, so one you call it as a private key, the other one you call it as a public key, and or you will have your private key. You'll not share your private key to the any other party, but you'll share public key across everyone. So the one and this public key and the private key are actually mathematically interrelated to each other. Someone who is having their data, and they'll take your public key and they'll encrypt the data with your public key and they'll share it to you, and you have the private key which is used to decrypt the data. So which altogether called as an asymmetric encryption. Okay, in TLS and SSL handshake, we use both asymmetric and the symmetric encryptions, so which we go in detail and will understand in the next slides. So this is about the confidentiality and asymmetric and the symmetric keys, where the public private key pair comes into picture. And the second slide, we talk about the second goal. We talk about the integrity. I'm showcasing some example here. So if you see, there are two parties here, one the Bob as a sender and the Alisa as a receiver. So Bob is trying to send some text message to Alisa, but what he's trying to do is he's trying to he don't want his message to be tampered over the transit. So what he's trying to do, he's trying to send the plain text through some hashing algorithm, and that hashing algorithm is eventually along with his private key. Now his private key along with the text message, he is using some hashing algorithm, he is turning up into some digest, and that digest is again turned into a digital signature which was shared to Alisa. Now Alisa tries to decrypt the digital signature, where she end up with her public key, where she or the Bob's public key, where she can get the plain text and the digest message. Now Alisa will use the same hashing algorithm of the Bob's, and she can get the digest out of the text whatever she receives over the wire, and now she'll compare both the digest, what Bob's digest, and what she has got from the text that Bob has sent to her. Now once both the digest is matching, which eventually means that the message has not been tampered in the transit. So this is how the integrity would be uh, achieved. And as and this is just some information about it. So hashing is used to provide the integrity. Both parties establish a mutual secret key, and the sender combines the message and the secret key to create a digest, and the receiver verifies by calculating the hash message. As I said, they'll compare the receiver will compare both the digests, and that once the digest matches, that means the message is not tampered. And the third goal that we have is authentication. So authentication is, if you see this example, we know that now the message is not tampered in transit, but there might be a chance someone is sitting in between the wire, and when someone tries to capture the whole data packet from what Bob is trying to send, and uh, and the hacker tries to mimic or or act like a Bob, and and tries to show Alisa that he is Bob, and he creates his public key and placed over some public place and share it to Alisa, and Alisa is receiving some message. She is able to match the digest, and she's receiving everything. This looks like Bob, but it's not Bob. Someone is sitting in between and mimicking Bob. So how can we overcome this kind of issue? Or by authentication means you have to provide your identity or showcase that you are the actual Bob. It's not someone trying or behaving like a Bob. You are the actual Bob. That trust or that identity has to be provided to Alisa. So that's what the authentication comes into picture. So which can be achieved by some digital certificates. Some we can get the digital certificates. It's something like in this way, which can be issued by some trusted third parties, like Global Sign, VeriSign, or GoDaddy. There are multiple the trusted third parties who actually verifies your identity, or if there is a website, they verifies the identity of the true identity of the website, and they provide some certificate to that particular website, and they can showcase the true identity to the to the outer world by, or they can show that they are the true owners of the public key what they are sharing to the browsers. So that's how the digital certificates comes into picture, and the whole the setup, or the whole set of goals can be achieved by the handshake, the SSL handshake protocol. If you go into this handshake protocol, so it was in detail, like, I'm not going very much into very technical into this handshake protocol, but yeah. So once the user tries to, initiate some, or tries to access some website address, the SSL or the TLS communication starts sending a message to the website server. Once the website server, once what happens means the client hello will be sent, along with some, some cipher suit, some version numbers, and all sort of things. Now once the server receives that client hello, now what server respond back is, the server respond back with the public key or the certificate to the user browser. Now what browser will do is, browser will check the public key of the certificate, and if it is okay, like, the browser's trust store is, or the, trusting this, the server. Now what they do is, it will also respond back with the server hello. Once the server hello is done, now the client will create a symmetric key, or the session key what we call it, which is alive for that particular session, or whatever the time that you are using for that browser. Now that session key will be sent back to the client, and if all good, I mean, the SSL handshake will be completed, and the session will start, and the communication will happen. So this is what the SSL handshake protocol is about. I just showed it in the pictorial way as well. Like, the client hello would be initiated from the client device, and the server will send back the hello, including some public certificates, and, the client request, and the client certificate request. And once the client, respond back, and the client hello is done, client will share some, the session key, or the, to the server. And once the session is started, the protocol will start, and the session will start, and both client and server will have a secure communication. So this is how the SSL handshake protocol works. And here comes the common, terminology that we use, the key store and trust store in this protocol. So when we want to establish the secure, the the communication, we, the server
Irfan,
and yes, yes,
sorry,
bhai.
sorry to interrupt you. You're going very fast. You can reduce your speed if you can.
Oh, I'm sorry. Sorry. Oh, any questions still here?
Irfan, Rahul this side. Am I
Yeah.
audible? Yeah, so basically you told that there are three steps, right? Confidentiality, integrity, and the other one was authentication. So in SSL, can you just quickly explain like which part is handling which thing in these steps?
So they all come as, they're interlinked with each other. It's not like, they
Okay.
come with, the different steps altogether. They are like, all comes with, interlinked. So some part of it, like, when the or when the server is sharing its public key and all the stuff, where, you comes with some, the confidentiality. That means it's sharing its public key, which is, the server is holding the private key and sharing its public key, which is been putting in the public certificate. If you see any public, or any certificate, digital certificate, you will have the public key enabled in the certificate only. If you see this certificate, right, this is a global sign certificate. If you click on the public key, you have the public key already in the certificate. So the certificate
Okay.
itself will have those, the information. So they are come as package. It's not like one after the other.
Okay. Okay.
Yeah. So yeah, so we have the key store and trust store. So basically, for example, if client is trying to access a server, so what server will have is, a server will have a key store. So in the key store, what we have the information is, it will have the private key, and, some, some public certificate in the key store. So when the server when the server tries to send the public key or the public certificate to the client, what client will have is at the client end, client will have a trust store. So this trust store will have the CA certified some sort of certificates where it tries to validate the certificate that it receives from the server. So that's what the trust store is all about. So in one-way SSL, the server will have the key store and the client will have the trust store, because the client needs to trust the server. In this case, in one-way SSL, the server don't need to validate the client's trust. Okay, so that's why client may not have the key store, and uh, and the server might not have the trust store. In two-way SSL, both the parties, the server and the client, has the trust store and the key store. So basically, the trust store is like, have the set of, the certificates, CA certified. The certification authority would verify some certificates, and they have that set of certificates where the client can validate the certificate received from the cert. Okay. So as I mentioned, the in one-way SSL, only like, the same SSL handshake protocol would happen, but only in one way, which means the server only will, the client only will, authenticate the server. It's not in two-way SSL. Both the parties will authenticate each other. Okay, this is what I actually put it here in this message. Sorry, in the slides. So, any questions? Can we move to the demo now?
Irfan, we have one
I,
question.
Yeah.
Go ahead.
sorry, my question was a different one. I think Sheikh had that with that.
Okay, so Sheikh has question like, in server side trust store, which key is available in that?
In server side trust store,
Yes.
the clients, whatever the, suppose the client is sharing some information, or no, the client is sharing the public key, that would be, or the public certificate, that would be validated in the trust store of the server, the client's public certificate.
So yes, to answer you, Sheikh, like we don't store any key particularly in any in our trust store, right?
Yeah, that is correct. It's just the public certificate, it tries to validate.
Yeah, exactly. We store the certificate in that.
Yeah.
Okay, so your question, Rahul, if you have any.
So yeah, so first question was like the trust store that contains certificates, and inside certificates we have keys, right?
Yes.
Okay, so if we had to discuss, let's say one-way SSL, so it will be like, if let's say I am a client and there's a server, so what I'll maintain is a trust store inside which there will be a certificate which contains the public key of the server. Am I right?
That is correct. Yes.
Okay.
That is absolutely
And
correct.
and when it is, so basically the server does not need to verify that I am a valid client or not, right?
Yes,
Just
that
that
is
I
in
need
one-way
to.
SSL. Yeah.
Yep. And in two-way SSL, it's like trust store and key store both are maintained at both the ends, right?
Yes.
So if I had to say, let's say I am a client and there's a server, so my public key would be inside a certificate which is maintained inside the trust store of the server,
Yes.
and vice versa. Does it work like that?
Yes. Exactly what.
Okay, and my the key store would contain my private keys. I mean the
Yes.
certificate inside which I have private keys. Am
Yes.
I correct? Cool.
Yes. Yeah.
Okay, I understood.
Okay, now let's move to the demo, which would clear a lot of questions. Okay, can we move now? Yeah, I think I'll take it as yes. Okay, let's go and build some demo. So what I'll do first is, I have some set of, commands which we use for, generating the key stores and trust store. Okay, so first we'll start with one-way SSL. As I said, in one-way SSL, the client, the server will have the key store, and the client will have the trust store, and server will tries to share its public certificate to client. Okay, so for that, what we are trying to do is we are going to use the JDK key tool command, which is used to or create the server key. Basically, the server keys, what server key store will have? Key store will have the private key and public key, and the basically the private key and the public key, and where from which we can extract the public certificate out of it. Okay, so first we'll go and try to generate the key store. Okay, so if you see this command, so this command has the key tool and generate the key. We are giving some alias name to this, to generate the key, and we are using some key algorithm which is RSA. And we'll be storing this key store into this particular location with the name server keystore.jks file, and this will have the private and public key which are mathematically interrelated to each other. Okay, let's go here and just the command. It will ask for the password, provide some password. Here we are generating some self-signed certificates, and it's asking for a first name and last name. I'll provide localhost and some organization name. I'm just giving like server organization unit, server, and we can also skip some information, so I'm skipping just this information. Yeah, now it's providing is this information is correct. We're acknowledging this as yes. It's again asking for the password. Okay, if you go back into this location, so I got the server keystore.jks file. Now what is the next step I'm going to do is I'm going to extract the public certificate out of this keystore, which means which basically contains the sort of information that we provided and the public key. Now let me go and run the command to extract the public key out of or the public certificate.
Irfan, the command you executed should be in some executed in any directory in the entity.
I'm sorry, your question is not clear. Can you repeat it?
Yeah, the command you executed this one in the CMD. So in command line, it should be in particular directory, or it can be executed
No,
somewhere
it can be
in the other
in
directory.
any directory. It can
Okay,
be in any directory.
we shouldn't. Okay, is it on in the JDK path?
No. Okay, now let us run the second command, which is to extract the public certificate out of this server key store. Okay, so this command again has to export with the same alias name what we have used for the key store, with this particular location that we have stored our key store, and to generate the public certificate with the name server public certificate.crt. So let me run that command. It's asking for the password, so I'm providing the password which I have used. Now if you go back to the location, you have got the public certificate. Now if you open the certificate, this is not trusted certificate, because it is not in your root certificate, trusted root certification. That means if you see in your local machine, if you have the certificates, they have something called the trusted root certificate authorities, where it have bunch of certificates, with some of the what you say, familiar or the famous CAs, like DigiCert or GoDaddy or something, which was not in our root trusted, whatever that we have generated, right? So that's why it's showing as in some kind of a warning, like it's not in our trusted root, but still if you are trusting this one, you can go ahead and use this certificate. So that's what there's a warning. But yeah, once you go into the details, if you see here, the main thing that you can see is the public key. So if you click here, the algorithm which use RSA, and this was the public key, this is what we actually share with the other party, right? The client or someone who is accessing our resources. So this is something important. Now, yeah. So now once we have the public certificate, now what's the other thing that we are going to do? Now we have the server key store and the public certificate. Now what the other thing? We need the trust store, right? So and this trust store is at the client side, right? So we are going to set up some trust store. Before the password. It's giving the information and we are just acknowledging it. Yes. So it is asking, are you trusting this certificate? The trust store is asking, are you trusting this certificate? And yes, we are trusting the certificate. So the certificate is imported now. So now if you go back here and see, now you have three things: one, the server key store, and the client trust store. And the server publish certificate was imported into the trust store to trust this when the request comes from this key store. Right now, we will copy key store and the trust store, which is required for us now. Now let's go back and create a demo here. Now let me add a listener, which I'll configure with HTTPS protocol. So local host. So I will make the port 8082. This is the default HTTPS port we use. Now we have to edit the TLS configuration, SSL or TLS, what are the name you use, but yeah, this is the configuration which we want to edit. Now here you have two things: one is the trust store and the other is key store. So this part is like, server for us. So what we do is we configure the key store. Okay, and the type of the key store is JKS. And now I'm sorry, now it's asking for the path, right? So we actually need to store this in our resource folder. So let me go and create a resource folder here. So I'll just create search as a folder. In this I'll paste whatever I have copied, the certificates, right? So I have this one now, the client trust store and server key store. So this is the server configuration. So that's why I am going to provide the path, the server key store path.
Irfan, can you maximize that HTTP listener window so that everyone can see it all at once? You just need to drag it. Is there an option to drag, maximize it? Yeah.
Yeah, just do it.
That would be fine.
Okay. So the path is search / server keystore.request. And the type is yes. And you can skip the alias for now, and the password is my pass. You can provide the alias name also. My pass. So make sure your password is matching. Okay. Now this is the configuration that I did. Let me provide the path. I'll provide this as server. I'll just put simple set payload here. Well, let me create a client for this to trigger this server send some request. So let me create the another configuration file, which is let me drag and drop a listener. This I'll put it on the 8081 port. I mean HTTP protocol only. And let me drag a HTTP requester. Well, I'll configure the client setup. Now here, if you see this part now Now we want to provide the configuration of the server here, which is HTTPS, the one which we have created as SSL demo.xml. The port as now this is a client, so we have enabled or we have set up the key store at the server side now, and the client side we have to set up the trust store. So if you open the TLS configuration, again you have these two things, one is trust store and the key store. Now I am going to set up the trust store at the client side. So here again I want to provide the path of the trust store, which is search slash and the password. Okay.
Irfan, the path name would be client truststore.jks, I guess.
Yes, it's client trust. Thank you for that. So now let me provide the path of the server first. Now this is the URL or this is that we are going to trigger. It got deployed successfully. The application is started. Let me go back to this normal browser and tries to run this. We got this. I got the hello secure connection, which means the request has been this is just to trigger the client request. Now the client has just triggered the request to the server. Now the server has actually had the handshake happen, the one-way SSL happened, and it successfully processed, and we got the expected response. Now in the two-way SSL, if you go
Just
back,
before that, Irfan, if
yeah,
and if you hit from your Chrome directly the server, it won't be able to connect.
yeah, it would be able to connect. I just want to show the client, the client server, the configuration, the trust. What happens is, your question. So what browser comes up with is, so browser will come up with some set of certificates. Okay.
Okay.
So just like as I showed you in the local machine, so our local machine is coming up with some certificates, right? Some trusted root certificates. So that way usually the browser also will have some trusted rooted certificates. Okay, so what happens when you trigger directly from the browser to the HTTPS protocol is there will not be the browser's trust store will not be able to actually validate the certificate or validate this server, because this was just the self-signed certificate and which was not trusted by any CA or the certificate authority. So if you do that, what you will land up with, you cannot see the green padlock, which is secured communication. I can do that as
Okay.
well. You got my point?
Yes, yes, Irfan.
You can do that as well. So you'll just see again it's not secure. So but it will
Yeah.
still ask, okay, if you still want to trust me, you
Proceed
can
with
go
this.
ahead and proceed it. Or if you see here, you can see the certificate is not valid. It's just because no CA has actually validated it. So that will. So that's why we
Thanks,
are
Irfan.
creating
Got it.
our client here, and we actually put our public certificate into the trust store of our client. So that's why we are creating our client. So yeah, in the two-way SSL, it's now we have actually have the key store at the server side and the trust store at the client side. Now what we are going to do in the two-way SSL, we are going to enable our set up both the client, both the key store and the trust store at both the sites. So for that, we already have the server key store and the client trust store. Now what we are going to do is we are going to create the client key store and the server trust store. For that, again, it's the same command, but we are using it for client key store. Again, the client will be creating a client key store, which will again have the private key and the public key. It's just the same steps I have, whatever I did, but it's for client. Now I got the client key store. Now I need to extract the public certificate or the public key out of this client key store. For that, again, I'll run command for that. I got the client public certificate. Now I'll go back and set up the server trust store where I'll import the public key into server trust store. So that is successfully. Now we have the client key store and the server trust store. Let me copy this. Let's paste this. Now what I'm going to do is now let's go back to the client. Now I'm going to set up the client key store, because client is already having the trust store. It's not having the key store. Now the server side, we need to set up the server trust store. A bit like now again, if you go back and begin got the success message stating that both the handshake is success. So that's why we are able to get the success message like hello secure. So this way you can enable the two-way SSL. So yeah, so this is how you actually do the one-way and two-way SSL communication.
Irfan, it was showing as not secure, right?
Yes, so that's what I told you. So it was showing not secure. It's because your browser will come up with some default, some like I'll just show you.
Okay, got it.
Mm. Yeah.
I do have one question, Sheikh.
Yeah.
With the two-way SSL, even if we hit the server, it will with the then it will be a like a safe connection, right? It will not give warning, even
Yeah.
if the browser is coming with the default certificates.
Yeah, like it will give some warning when you don't have that, when the certificate is not trusted.
No, if
In
if we have two-way SSL, like we have configured
Mhm.
two-way SSL, server and client side, and we are hitting the server URL, we are accessing the server from the browser directly. So in one-way SSL, it was giving warning because of the default certificate. But in
Mhm.
two-way SSL, we have the certificate in the means like we have two-way SSL configured. So from browser, if we'll hit the server directly, again it will give the warning or it will be a successful connection.
No, 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 no. The warning would be in every case. When you directly access. See here in my demo, what happened is, you try to access, some resources from directly your Google Chrome. Okay. Suppose directly from your Google Chrome, when you try to access the server. Okay.
Okay.
Which means directly the HTTPS protocol. What happens means the Google browser tries to, validate the certificate that you have put it here. Okay.
Okay.
So the Google browser will not understand your certificate. Now, that's why we created a client, and what we did here is we have created a trust store for the client, and we have put our public certificate into the trust store of the client. So that's why
Mm-hmm.
you'll get the safe connection
Okay.
when
Got it.
you hit with
Got
this, normal, HTTP protocol to this client.
Okay, got it.
Yeah.
Thanks.
What happens if we hit from Postman or advanced system?
In Postman, you actually need to disable the SSL connection. Otherwise, you'll get some error, something like this. If you still have the, if your application is also deployed, but once you don't disable the SSL certificate in Postman, you'll get some error like this.
Irfan, I just need to ask one thing.
Yeah.
Yeah,
go ahead. Who was
Yeah,
talking?
so my question is that this arrangement of certificates that you just showed, this works best when
Yeah.
you have an API-led architecture and let's say process API is calling a system API, and then the certificates are exchanged, and then you get the response. So let's say if we want to access this API from Chrome or any browser, or let's say from Postman without disabling the SSL options. So for that, we need to have a signed
Yeah.
certificates from any, for example,
Any
like GoDaddy.com or any.
Yes, any authorized CA should sign it. Yeah.
Awesome. Well, I have another question that is then related to load balancers. So can you like explain that as well? Configure the SSL certificates in our load balancer, because in that way we have, and I'm talking about.
Okay. I think
Jamal, Jamal, so we are going to cover the load balances and the secure mechanisms in this session. So we want to restrict this information only for this session, whatever we explained right now.
All right.
yeah. Can I stop my presenting, Giri? Like,
Yeah, before you
Yeah,
stop,
yeah.
Irfan, one sec. Can you just show me again uh, where you called, this client or the server, where you got that file, client secure connection one? How did you got that?
which file? Secure connection.
I mean, you got that file downloaded, right? Client, which has got that message. Yeah,
Oh,
this one.
this
Yeah.
is just when you trigger from the browser. Browser will just send you the response in this.
So where did you call? Can you show me that browser?
No, it's just the Google Chrome browser which I just used to, trigger the request, and this will just, automatically download whatever the payload that you have set up. This is normal, like when you try a hello world program also, you'll just get the response in this way from you also.
I mean, how does it says that? Okay, I mean, since there was a secure connection, then only you got this message.
Because this okay, I can debug this and can show you, like, because there, because I'm triggering this listener, which is at the client side. This has to pass through this request. Now this request will route to the server, which I mean, this requester will is having the this listener configurations. So once this is passed, then only I'll get the message.
Okay, okay, got it.
Irfan, we have a couple of questions in the chat.
Okay.
So, okay, I'll read out to you.
Okay, I'll check that.
Irfan, one
Also
more
the-
thing. So you, I mean, this was trusted server information, right? Now server is also trusting client. So
Yeah.
that message is not shown. Getting me?
Yeah, I
So
understand. Yeah, I
I mean, how?
understand.
Yeah. So how client is? Sorry, server is trusting client.
Because again, if you see here in the client side, we have again configured the server trust store.
Right.
Sorry, I mean, the client side we have configured the client key store, and at the server side we have configured the server trust. Sorry, if you see here, we configured both the trust store and the key stores. So once this has to be passed, then only we'll get this success message.
No, no. So in one-way SSL also we were getting this message, right? Even when the
Yes. One-way SSL also we are getting the same message, and two-ways is also we are getting the same message. Because of the time constraint, I didn't build up a big example. So what I'm trying to make you understand here is, the request, the client and the client side and the server side, both the sides I enabled both the key stores and trust stores.
right.
So it has to be passed via all the steps. Then only finally we'll land up with the success message. So that's the setup actually I have made.
Because here there is nowhere it is shown that server is trusting client as well with this message, actually. So there should be something on the client side. I mean, some response that
Okay.
server is sending back to the client, right? And then client is
Uh,
maybe after
yeah.
this request,
Yeah.
some
Yeah,
message
sure.
from the server, right?
Yeah, because due to the time constraint, I have just set up a
Oh,
small
okay.
example.
No problem. I'll try.
Yeah,
that.
yeah.
No issues. Thank you.
Yeah. Any other question that you have? To answer the root and intermediary certificate, it's like setup. Once you have a root CA and you don't, let's suppose you have a root CA which is like a global sign, and it is having a private key, and it is sharing the, or it is trusting the lot of certificates. Once the private key of the global sign or something is compromised, which will really impact the other the certificates. So in this kind of scenarios, what they will do is they'll set up some intermediary certificates. So what they will do is the intermediary certificates. So for example, there is an XYZ website which the intermediary trusted authorities will actually verifies the certificate, and these intermediate trusted authorities will be certified by the the global authority, CA authority. So that's what the setup they actually made it to provide more secured trusted certificates. Yeah, Shubham. Can we wrap up here and go to the Kahoot, or
Yeah. Can you
any other
scroll above?
questions?
I think, yeah, I think we have some questions.
Oh,
Can
okay.
you try to scroll? Yeah. Just go to. I think we have some questions from starting from Yogesh. So just quickly, from Mukesh. Yeah. No, no. Scroll down. Yeah, you answered the
Yogesh.
Sheikh's answer. Yeah.
True, that's truststores or CSR's public key.
If you don't get the question, just let us know. Like, we'll ask the Yogesh to speak up.
Yeah, yeah, please. Yogesh, please.
I'm fine, Irfan. You can move on.
Oh, okay.
Okay.
Thank you. Insecure checkbox in truststore config page. Okay, yeah, we have this insecure checkbox. Even when you want to override the the trust store, or you don't want to override the trust store setup, then you actually will enable this checkbox.
It will just make the connection sensitive to attacks. We can recommend. I mean, we all will do it while testing the app in app local, but not when it is live.
What's the difference between the password and the password given in HTTP request? Key password and the password. It's the same. It's the same password. What we have used while creating the key store is the same password that we use. Secure checkbox, I think we have answered it. Trust at all, and hence it won't validate. Yeah, that's secure HTTP, but not secure. Yeah. The browser usually use one-way SSL. The root and intermediaries, I have explained it. Certificate chain error. What's the best approach to avoid this issue?
You can speak up, Manikandan, if you want. Manikandan, your mic is enabled, I think. Shubham, audio is not enabled by Manikandan. Can you please check once? Shubham?
Hi, friend. My question is like when we have multiple root certificate and interim certificates, like
Mm-hmm.
end up in kind of certificate chain errors, right? So just want to know what is the best approach when we are constructing this certificate things so that we won't land up in this particular error.
I think you should always verify your trust store that contains the proper signed certificates, or the chain that provided the chain, or your trust store should able to have the valid certificates. I think that's it. I'm not very much clear or sure on this answer. I think anyone in the panel can and the team group can
Well, I
answer
think
this question.
you can create a certificate chain by certificate chain composer. So you provide your certificate, and then you will get the chain of the certificates that would direct it to the root CA certificate.
Thanks.
Yeah, thank you. Yeah. Okay, I think
Yes. Mhm.
we are
Good.
we are done
Okay.
with the questions.
All right. Let us know like if you still have any questions. So meanwhile, we'll
Yeah.
start the quiz. Okay. I'll stop the recording. You can stop the sharing.
Yeah.